Yeah, so good morning. Daryl asked me to talk a little bit about like an update of this crop, especially how it's faring after that cold spell that we had in mid-February. And I have a few slides here as well, just to give a general update on that project that Daryl mentioned that the KWA has funded for a couple of years there, and we are in the wrap-up phase. So very briefly, if we cover what happened back in February that got kind of like everybody concerned with the status of the wheat crop there. Really, it was some extremely cold temperatures, right? So here in this map, you can see the lowest air temperature that was measured on the 17th of February there. And you see that it ranges from, let me get a pointer here, it ranges from anywhere on the -11, -13 here in south central part of the state, all the way to about -26 in the northwest part of the state, with -29 in north central Kansas there. So extremely cold temperatures that could definitely lead to some damage to the crop. So the question was, what is the potential for the winter kill, right? Definitely the temperatures were there, the air temperatures were there to result in some problems. What are some of the other things that we needed to consider? And one of them for sure is the crop conditions, right? What was the status of the crop? And if we look back this year, what we have here is the percent crop emergence that we had in different areas of the state. And I don't have here the eastern third, right? It's just like the western third, northwest, west central, and southwest, and north central, central, and south central Kansas. And really, folks, if we look back in the precipitation patterns that we had in the fall, there was some precipitation in September for the majority of the state. Fields that got planted in the early side of the planting date there, that mid to late September, perhaps up to early October, were able to get a good emergence. But really, it was so dry later on, no rain during the most of the month of October, really with just some rain coming up in November, that a lot of the fields that were planted probably after that October 10th or so, they really never emerged in time. Many fields were planted on time because soybean harvest allowed for a timely planting this last year, but it never really emerged in time. So in parts of the state here, you can see that more than 60% of the crop was really emerged late, especially in that north central part of the state. Now, as we go west, it's more like in that 20 to 30% range that was kind of like late emergent, because a lot of those crops are going after fallow. And so we're able to be planted on time. So really a kind of like two very different crops. Early planted one that actually was in pretty good shape when this cold spell hit, and crops that were planted either on time or late, but never really emerged on time. So we're more concerned with that late emergent crop. Just because with less tillers out there, has less potential to survive any cold temperature like that. Another factor that was concerning to us was dryness, right? And so if we look at the precipitation from September until February, so September 2020 until February 2021, especially the western third of the state was extremely dry, anywhere from, less than 4 inches of rainfall for most of this yellow region here. Many of these regions just getting about an inch or an inch and a half. The situation improved as we moved east in terms of moisture, and especially in the south central part of the state here, again, where we had the temperatures were not as cold and there was more moisture accumulated. Another factor that was concerning at mid-February was snowfall. If we look at the amount of snow that was accumulated in that February 17th timeframe, we see here that in Oklahoma, those folks got up to 10 inches of snow. In Nebraska, they got up to 20 inches of snow there. But here in Kansas, we are in that 1 to 2 inches for most of the state. And part of central Kansas there, even less than that. So usually 1 to 2 inches of snow, we say that we're typically okay and typically well protected, especially if it's like a moist, heavy snow. This was a pretty powdery, pretty dry snow, and that was also concerning, right? We're kind of like on the verge there. So air temperatures were extremely cold. The soil was for the majority dry, and there was not a lot of snow cover. Now, one thing that was promising was that the soil temperatures, they never really dipped into single digits. So this is the soil temperatures at the mesonet stations. It's important to remember that this is at the 2-inch depth. More realistically for wheat, we need to be looking at about the 1-inch depth, which would be a better estimate. which will be colder than what we're seeing here. But we were concerned in some parts of the state here, reaching 14 or something along those lines, up to 12. So this was kind of concerning in some parts of the state, but never really reached single digits. If we look in the past years, whenever we had winter kill, these soil temperatures, they were reaching single digits. So that gave us a little bit of comfort here, and a little bit more promising in terms of soil temperatures. Now, this last week, we have been going around the state in several of our own trials and commercial fields as well, just to see how things are looking. Because at this point in time, back in February, we were saying, well, we need 4 to 6 weeks so we can actually get a better estimate there. And it seems that, like, for the most part, we may have dodged a bullet in there. And so if we look at that south central part of the state, where we were not too concerned to start with, but this is our dual purpose trial as of last week, trial planted in September. You can see there quite a bit of biomass. The wheat is nice and green. There was maybe a little bit of leaf burn, but overall in pretty good shape. The small crop in Hutch that was planted after soybeans. This is a photo from yesterday, coming up nice after the rainfall especially, and so seems like it fared well. If we move north central, where we were more concerned, this is a picture from last Friday from our fields in Belleville there. So we can see that the crop that was planted after canola in late September, of course, had much better development and more peelers out there than the crop planted after soybeans in mid-October, but both seem to be doing okay. If we move a little bit west now and go to Mitchell County, and this was some plots that were actually planted towards the late part of November. So this will be representative of a lot of the fields out there, the north central part of the state, where even if they were planted earlier, they never really emerged until November. So very small crop you see there, right? But it's green, it's coming up nice. There's some leaf burn there, but so far it looks promising. And this is a region and a system that we were concerned. Late planted crop after soybeans, very small development, seems to be coming out nice. And for sure, this last week's rain is definitely going to help. Continue moving west in the north central part to northwest Kansas there. This is another field that collaboration with Lucas Hag on Decatur after a fallow period. And we see here that, again, kind of the same situation. Although it was after a fallow period, it's still pretty small. It was not planted in a good time. But it's nice and green. You know, it's small, but it's coming up. If we look, take a closer zoom, we see some leaves that were burned and died back. But overall, these green leaves are promising. Especially this region got, I believe, up to 3 or 4 inches of precipitation over the weekend. So it's definitely going to help out the crop. Then continue moving west here. If we go close to the Colorado border there, these are some plots that we have near Leoti. And this was truly a fallow ground planted late September. So a very nice root system, very nice development of the crop here, 4 or 5 tillers per plant. And so overall, and in these locations where temperatures at the 2-inch got to 12 degrees. And so overall, it seems like, at least where I was able to visit this last week, it seems like the crop is faring quite well. And especially after the rain that we had this last weekend, and there's a lot more here that was not computed. This is just 24-hour precipitation there on our biggest event, but it continues to fall. Definitely this is going to help the crop recover if the crop still has the potential to recover there. So preliminary assessment there, it seems like we may have dodged the bullet for the most part, and it's looking more promising now after this weekend's rain. So that was a brief update there. I have just a few minutes. I don't think I have too many minutes here. Daryl, do you want me to cover as well a couple of slides on the project update, or would you like me to, if we have time later, to do that later?
If you got a few slides, go ahead.
Okay. So Daryl mentioned there that we have a project looking at long-term databases, and he got it almost right there. He said 80,000 observations. We were actually working with close to 100,000 yield observations in the last 20 years for 3 states here: Colorado, Kansas, and Oklahoma. And we're pretty much done with a pretty interesting analysis for these, which was defining the optimal sowing dates and optimal management practices per region, as well as variety characteristics. So that phase was the first objective of this project. That phase is done. We're in the second phase of the project now. The funding ended in December of 2020, so that funding has ended, but we are finalizing this project here. And this is where we're looking at the concept of yield plasticity. So this is, you can think of it as kind of the opposite of yield stability, right? We typically like to think of yield stability of a variety that is quite stable under various conditions. Yield plasticity is kind of the opposite of that. It's a variety that can be pretty responsive to the environment. So we looked at the last 20 years of data. Each point that you see here in this graph shows where we're getting our data from. The size of the point is how many years are included in that experiment, and the color is like how many genotypes. So you see here that we have from 11 to 122 genotypes in each one of those sites, and 1 to 19 years of data in each one of those sites. And really, what we're looking at here, you might remember this from last year, but we're looking at how responsive a variety is to the environment, right? If the environment is good, can it actually be really one of those varieties that capitalize and really have an explosive yield in responsive to the environment, as compared to in a bad environment, can it maintain its yield? Right, so essentially, we're looking at the concept of plasticity here. And plasticity can be positive if yield increases with changes when the environment gets positive, but it can be negative too, right? So for example, if a variety is not very drought tolerant and we have a very bad environment, that variety can actually decrease yield quite a bit in that environment. So we're wanting to see if it is a positive or a negative trait in this region. So the first thing that we did that was interesting is we looked at how many environments we need for quantify plasticity for one variety, right? And this is what we're looking at here. So if we used one environment, you see a huge variability on the estimate of that plasticity, right? If we use 2, 3, 4, all the way that if we use 100 environments, you see that the estimate of the plasticity for a given variety is much more stable, right? And so essentially what we found is that we needed about 40 environments. So one variety needed to be tested in a total of 40 environments, before we could say, well, yeah, we're pretty confident on what this variety does in terms of plasticity. And then we look at that plasticity of that variety and see if it correlates to yield. That's kind of what we're looking at here. We had the plasticity of those varieties. If a variety has a plasticity of 0.5, it's pretty stable, meaning that it doesn't answer much. And you can see that based on the difference between the lowest and the highest yield for that variety here. And as we have a more plastic variety, that range increases, right? So if that range increases and in the bottom here it's decreasing, that's not something that we want to look for. But really what we're seeing here is that in our environment, this trait, plasticity trait, was able to maintain yields at the low yield environment and capitalize on yields when the environment was good. That's why we see this spread here in these two lines. So if we look at all of the environments that we evaluated here, which is over 700 environments, we have that line, right? If the line was positive or neutral or negative. So we wanted to see how often it is positive, right? Because that's why we're interested. And that's what we're looking at here. We have our frequency distribution here going from 0 to 100, right? And then we see here that about, well, just about 15% of those environments, it was negative. And in the bulk of the environments, that trait, plasticity, was either related neutral or positive to that environment. So overall, it has been a good trait in our varieties in the past 20 years, meaning that moving forward, perhaps this is something that we can look into in breeding programs as well, right? A variety that has been stable in low yielding conditions and can really capitalize on high yielding conditions. We have a lot of more analysis here looking at the environment and so on, but I'm not going to go into detail because I'm already 5 minutes past my time. But that was it there. Also, I'm not going to go into the remaining of the project here for lack of time, but I'll be around. We can always continue discussing that if there's interest. So